we do. Yeah, it's nice that the next speaker always is involved in the discussion already. So Brad is our next speaker, and he talks about Telnet news on ESP32FORTH. Brad. Yep.
Hello. Can
that works?
you hear me? Great.
Yep. All
right. Let me go ahead and talk about a few different things. So I'm going to talk about three different things. It's some improvements that have gone on in the last month or so since I spoke with this group, and then I'll briefly touch on a thing about modules that I was pondering and a thing related to that, and then talk about cryptographic hashing on the ESP32. So a bunch of different changes since April. A lot of them are fairly minor. Things like I noticed I had somehow missed FROT with the floating point support. There was a bug in SF float plus, which it was leaving an extra value on the stack, which I was surprised that I got as far as I did with it being in that broken state. And I noticed an anomaly with RShift. I had inadvertently implemented a signed right shift instead of an unsigned right shift, which seems to be the more typical pattern. Although, if anyone out there is aware of a convention, part of why I had made that error was that I was making use of R shifts in a context where it was useful to have them be signed, and I'm not sure if there is a standard name for such a thing. I would love to use something. The best I could come up with was AR shift, but anyways, there's been some changes under the hood to work on includes, and I think I'm sort of incrementally working towards a world where files might be used more pervasively on the device. There was already included present, but they were sort of inefficient about, or not inefficient. They were different than G4th in the sense that when you include a file and then include a file from that file, the paths were not relative, which can be problematic if you're trying to do something with a recursive include. Part of how I came to be fiddling with that was that I noticed that I found myself having to be very careful with include order and missing the word needs, which doesn't include if the file has not already been included, which is now supported in the innards of the system. I got an email a bit back from Peter about lack of soft AP support. I had in importing the Wi-Fi words just not included all the soft AP related ones. This allows you to have the ESP32 be in a mode where you can treat it as an access point, and just hadn't added those. And then a whole bunch of things have been a problem with the with Telnet and with terminals, and I think I'm at least dangerously close, if not fully there, in terms of being able to work a little bit better with some of the terminal quirks that I've encountered that come up with Telnet. One of the issues is that depending on the Telnet terminal that you use, depending on the if you're connecting over serial or different transports, you end up having different conventions. And I guess I tried to there's a aphorism, be liberal in what you accept and conservative in what you omit, and I tried to do that. It seems that carriage return line feed is the more conservative thing to omit, but then I've tried to have all of the input handling be flexible and tolerate the situations where you're getting just individual carriage returns or carriage return line feed pairs, or line feeds are really weird. When I was noticing some of the Telnet implementations out there seem to, in certain circumstances, send a carriage return followed by a nil as the return value, which is I never noticed that before. So let's see. Let me pivot over. The Telnet. I thought I'd demo just Telnet generally working. I've got a block with my Wi-Fi password, so it's not for all to see. And then let's see if I'm in an existing session, so I will. So let's say I go to this. So I've started that, but I need to go into the Telnet D. Can't spell Telnet vocabulary, and in there's the implementation, but there's also the server. I'll do Telnet server, and that will run a Telnet server. And oops. Oh, okay. So much for my claims of having all of the terminal woes fixed. That's some awesome demo. Oh yeah. So one particularly odd thing, and others, please email me as you find experiences here. I've noticed that under certain circumstances, at least Linux under Windows seems to do an interesting thing when you connect to port 23. It has a terminal mode where it does some line buffering, which does some that I have not found a good pattern to work around that sort of works cleanly with other things. Interestingly, it does something different if you connect if you use a different port than 23 for reasons that I do not understand. And in that world, then things are working. So if you run into trouble, I guess one suggestion is with Telnet, it seems to be some of the terminals do unusual things, unusual things with ports of the port 23. Let's see. Moving on. A thing I found myself wondering, and the crypto piece I'm going to talk about in a second will highlight this, is that currently I've made extensive use of vocabularies, as was noted earlier with the editor, but also a lot of things are kind of stuffed away in various corners. And one of the things that I've noticed, having used vocabularies, I think more extensively than I've used vocabularies previously, because of all the different things that are pulled into ESP32FORTH, I found that it's kind of tedious that they don't tend to be sort of nice patterns that at least that I've been able to find for sort of squirreling things away. And I got sort of similar to the question that was asked earlier, I found myself wondering if a slightly flatter namespace might be good, but then the thing you quickly run into is that there are sort of things that are on the inside of the module and things that are on the outside of the module. And so I found myself wondering about this. There's this old 3-line module system, and thinking about minimalism. This is actually not the original, but this is sort of done in a style that works for ESP32FORTH. But I'd be curious if others sort of what your experiences have been with vocabularies. Do they work well for you? Yeah, so I guess, you know, this is the style in which this module system is used. It basically provides a way to have a temporary namespace in which you implement a variety of things, and then you decide, you know, which subset you want to actually expose. And I've found myself wondering if this style of module system is simpler and cleaner and might do well for many of the pieces of ESP32FORTH that are kind of meant to be on the inside versus the outside. But curious, maybe put things in the comments. Does this module style seem interesting? Does this seem like a thing I should use more in the system, or should I stick with more conventional vocabularies? The vocabularies in ESP32FORTH are this weird, they're a hybrid of Forth 79 and Forth 83 style vocabularies. They sort of do the Forth 79 hierarchy, but there are ways to tell them to behave more like Forth 83 vocabularies. And so you can sort of use them interchangeably in principle, to sort of the way you would use either of those two. But yeah, but I've also found that as I've used them more, that they feel unwieldy. On to something different. A thing I've been puttering on in the background, and I figured this was as good a moment as any to chat about, was I've been thinking about hashing and hashing implementations. There's in particular, I was looking at two there's SHA-1 and SHA-2 algorithms. SHA-1 is interesting mainly because it's used by Git, and although actually Git is in the process of transitioning off of it, it's no longer considered cryptographically sound. The interesting thing about these algorithms is that they have the nice property that you can hash a thing and then have an extremely high confidence that you've got sort of a unique identifier for it. And I've found myself wondering, well, what would a sort of a Forthy block style sort of analog to Git look like? And so as the sort of first building block down that path, I thought, well, okay, I should have an implementation of SHA-1 and to play around with such things. There's also SHA-256, which is really one of the variants of SHA-2, and it's used by Bitcoin and folks. So that's similar and fun. It's got the larger digest. So anyways, I've implemented both of them, and they're actually sitting, if you go looking around, they're not actually loaded by default in the ESP32FORTH, as I don't want to bloat things, but they're sitting in the micro eForth repository if folks are interested down in libs or something. And so an implementation in Forth wasn't bad. There's a bunch of values that are used actually in both algorithms. I kind of have shared a little bit of code between the two. I created buffer and some convenience words for manipulating that buffer, because each of these algorithms both work sort of a block at a time. I needed to make this work for desktop systems where you've got a 64-bit word size. So in some cases, I need a way to do masking and stepping, adding clip to 32 bits. And then this is another place where, again, maybe post in the comments if you know of any sort of good precedents for this, but I found that I needed or the equivalent of like an x86 roll or RAR, the sort of rotation with wraparound. This is a common cryptographic operation. And then I've got a few words to do endian flipping, because for reasons that are peculiar, the SHA algorithms operate in big endian for a bunch of things. And so it's sort of, probably if I thought about it more deeply, I could sort of compensate it and do things the other way around, but it was easier to just do things with the architecture and then flip them all at the last moment. I've got a convenience word for extracting one word's worth of digits for emitting the digests. And then there's some initialization to sort of arbitrary magic values. They're not actually magical in the SHA algorithm. Because this is the NSA that was the originator of it, they go to great lengths to use constants that are sort of the phrase is, I think, nothing behind my back. So most of them are things like the hex bottom digits of like the square roots of prime numbers or things like that. Sort of arbitrary but not arbitrary constants. And then this is the core of the algorithm, sort of all on one screen, and it's not too bad with sort of that setup. You've got you sort of expand out the blocks. You get 64 bytes of data. You sort of splay that out across a larger 80 word space, and then there's a series of rounds that do various transformations, and there's sort of 4 variants to those rounds where you're doing this common stepping operation that's doing a bunch of scrambling and shifting, and then you're doing some various masking and again some a sprinkling of arbitrary constants, and then I pull everything out into values, and that's it. And so this chunk operation is just sort of stringing together these 5 phases. This of course only processes a single block, and so then there's a sort of a second challenge, which is that if you have a larger piece of data that you want to hash, you have to load it in the appropriate order. You do this by sort of bringing it in, and then this is where I apply my Endian's shift, and then I've assumed the buffer is slightly larger than I need, because there's when you get to the very end of the block, you need to mark it with a single bit, which I do. Well, I mark it with a single byte because I don't support bit level encryption. And then there on the very last block, you need to sort of tag things appropriately. And so I don't know. Yeah, there's a buffer for the digest and printing of the digest. Sorry, that was a bit of a segue. And then here's the sort of outer wrapper where you would invoke it. So you pass in a block of data, and you would get out a hash and a length. So sort of byte buffer in and string out. And you walk through, chewing through each chunk one at a time. And then at the very end, you have to handle there's a couple of edge cases around whether you've sort of got a whole block or a partial block. And then these last 2 lines, you're sort of stuffing in the ×8, so the number of bits in the message. And then you can pull out you can format your hash and pull it out. And so I'll demo that in a sec, but sort of at a high level, the way to think of these chunks is that you're sending in the data chunk at a time, and then on the very last block, you're marking the end of the message with a 1 bit, a bunch of zeros, and then at the very end you get the size in bits. And so if you've got the thing that's exactly a multiple of 64 bytes, then this is all the way, you have an extra block just to include that size at the end. But the ESP32 has hardware to do both this one, which is SHA-1, which I just went through, but also SHA-2. And so I wanted to look into using that hardware. The way that it works is that there are a set of, there's actually a peripheral that handles doing this, and then there's a series of dedicated D-port registers to communicate with it. So you have you can control from the ESP32 the clock of the individual. There's a separate unit for SHAs, a separate unit for AES encryption, and I think one for RSA encryption. And so there's a set of enablement bits for the clock, and then a separate reset bit for the unit. And I believe the underlying idea is that you save power by turning these on and off selectively. So if you're sort of doing a stream of encryption, you turn it on and so on. There's a buffer of 64, actually, depending on, so it supports all the way up to other variants of SHA-2, which can have a chunk size bigger than 64 bytes, but effectively a 64 byte buffer for the current chunk. And to be clear, that rather than sort of the hardware implementing the entire algorithm, it implements the algorithm just for the one chunk. And then you have to still do the breaking apart of the message into chunks and the tagging of that appropriately. And then there's some control registers. There's one that you poke a 1 into to start the operation, and then for each successive block, you do the continue operation, and then when you're all done, you do the load operation, which will, from some hidden internal register, transfer in the completed digest into the text area. Throughout, what you're supposed to do is every time you do one of these operations, because there's a separate unit sort of handling this asynchronously, before you go on to the next step, you're supposed to check this, read this busy flag and check for it to be done before going on to the next step. This is the theory of operation of this thing. The idea being, right, that you would enable these, you would load you would load each of the 64-byte chunks in. You'd write a start value or continue value for the later blocks. Check for busy. Write a SHA-1 to load, and then wait for it, and then get the hash in SHA-text. In practice, I'm partway there, and it is a little bit flaky, but it is partially working. Let me see if I can get out of this screen. So do a reset. So the problem that I'm encountering, and I have a couple of theories as to what's going on, but the problem is that this is a shared resource within the device, and the ESP32 sort of libraries that exist in C, they actually wrap the accesses of these registers in a bunch of synchronization, because you have only one of these SHA units for the device, and you have multiple cores, and there are other things going on in the system. So in principle, perhaps why I'm hitting issues is that I am not honoring the synchronization primitives around this unit. I found that sort of freshly loaded, I'm able to get things to work. So if I go ahead and take this bit of code and bring it in, and then here's I've got the individual registers. So this is the sort of the same code that I showed before, but with substituting in use of the hardware. So up here in where is it, in chunk, I'm moving data into the SHA-text register, and then using either continue or start to pump data through, and then at the very end I move data out. One weird quirk I've noticed is that I've got the separate W move word, because that moves things a word at a time, because it seems that character level moves do not make the system happy. It gets confused by character rights. And so then on a fresh load of the thing, fingers crossed, if I do the sort of the simple case of hashing, actually let's try an actual message. So I'll hash hello, and I'll do SHA-1, and I'll type out the result. So and that if we go over here, oops, this is telnet still. And so let's compare with Python and see if we get the same result. So we'll pull in hashlib, and we'll do the SHA-1 of hello, and we'll print out the hex digest. Oops, and I need to do bytes, and we get the same number. So that's encouraging. However, the discouraging part is that if I go and do this again, I get a different answer. So something is not quite right with the hardware. So I have a one-shot SHA-1 with hardware, and then a random number generator thereafter. So perhaps I'm not doing something correct to reset it, or something else, but work in progress mystery. I'm going to now actively pay attention to the chat, and if there are any questions, please chime in.